Today, from the request of one of the members, I want to clarify the details calculation of percentage purity. And I'm using these simple questions as an example. We are given that 3.6 gram of a washing soda was dissolved in water and made up to a certain volume. Then during titration, we get this figure from a titration. And one point we have to note is that the washing soda, this washing soda which we are using, it contains impurity. The washing soda has some impurity. So anytime the washing soda is reacted with hydrochloric acid, only the sodium carbonate will react with hydrochloric acid, and the impurity will not react. So based on that, we can calculate the amount of sodium carbonate that is present in that washing soda. And that's exactly what we are going to do. So from here, the first thing we have to do, from the information we are given during a titration, we can easily calculate the concentration of the solution that was given to us. So the first thing we do is we write a balance equation. We are given that sodium carbonate is reacting with hydrochloric acid to form sodium chloride. It will give obviously carbon dioxide and water. Due to this carbonate here, to give carbon dioxide and water. And if I balance the equation, I add 2 here and I also add 2 here in order to balance it. So from there, I will get a mole ratio. The mole ratio of 1:2. So from there, I can easily proceed to calculate the concentration of the base. The concentration of the base. I know the concentration of the acid. Concentration of the acid, volume of acid. Concentration of the base, volume of the base, will be equals to their mole ratio. Number of moles of the acid, number of moles of the base. So if I substitute there, you can see I have 0.11 times 23.5 divided by concentration of the base times 25. We are given, I'm using 25. Then the ratio of the acid to base is this to this. So if we cross multiply it and divide, you will find out that the concentration of the base, therefore the concentration of the base which we are using will be, I cross multiply, then this divided by 50, you will find that you're going to get 0.0517 moles per dm cube. So in other words, in the solution given to me, in the initial solution given to me, this is the concentration of the sodium carbonate which I have. Remember, it is crude impurity because the impurity will not react with hydrochloric acid. So I've known the concentration of the sodium carbonate. So from there, I can easily calculate the number of moles, or from there I can also calculate the mass, because I wanted to know the mass. Remember, we are calculating the percentage purity. I know the total mass. So the second thing I'm trying to calculate, I want to calculate the mass of sodium carbonate that is present. So in order to get the percentage purity, how pure is that commercial sample? So from there, from the information given to us, we know that the number of moles is equals to Cv. And I know I've gotten 0.07571. I multiply it by 25. Remember, the volume there is 25. Remember the original volume, don't make that mistake here. The original volume here, but out of this, 25 have been taken. So don't make the mistake of using this volume because 25 has been taken. So it's that 25 we are going to use, and I have to divide it by 1,000. I have to divide it by 1,000 in order to convert it to dm cube. And if I do it, and if you look at it here, I didn't divide it here because this one is also a ratio, cm cube. But here I only have one volume here, so I must convert here. But you can notice there that I didn't convert because it's a question of a ratio. If I also convert, I also get the same answer. So from here I will get 0.00 219 moles. So this is the number of moles that is present. So once I get in the number of moles that is present, I can easily calculate the mass, number of moles over the molar mass of sodium carbonate. So from here, I will say 0.00219, which is the number of moles. Then I multiply by the molar mass. I multiply it by the molar mass of the sample, which we are given. So we get 0.253 grams. So in other words, what are we saying? We are saying that originally the total mass of the whole sample was 3.6, but only 0.257 is the actual substance. So we have a lot of impurity in these substances, in this washing soda. So the percentage purity which we are asked to calculate will be 0.253 over the total and multiply by 100, and I'll get 6.88 grams. Remember that a similar question might also come in the exam for me to calculate the percentage of percentage impurity. Percentage impurity. Sorry, this one is percentage. Percentage impurity. So if you are asked to calculate the percentage impurity, which we are not asked to calculate here, I will just subtract this one from 100. I will just say 100 minus 6.88 in case if we are asked to calculate it. So I have 100 minus 6.88. We also get the same. We also get 93.12%. So we can see here that this is highly impure. We have a lot of impurity.